Imagine a planet where the sun barely rises above the horizon for decades, then slowly circles overhead for another few decades before disappearing again. This isn't science fiction, it's the reality on Uranus, the seventh planet from our sun. Unlike Earth, which spins on its axis like a tilted top, Uranus is practically lying on its side. Most planets in our solar system have a slight tilt to their axis. This tilt is what gives us our seasons. Uranus, however, takes this to the extreme. With an axial tilt of 98 degrees, it's practically spinning sideways. This peculiar orientation sets it apart from all other planets in our solar system and has puzzled scientists for centuries.
Uranus's extreme tilt has profound implications for its seasons. Imagine a year on Uranus, which lasts 84 Earth years. For nearly a quarter of this time, one pole is bathed in continuous sunlight, while the other is shrouded in darkness. This creates extreme temperature differences across the planet, yet Uranus's atmosphere remains surprisingly uniform. The reason for this even distribution of heat is still a mystery. It suggests that Uranus has an unusual internal heat source, or an efficient way of distributing heat around the planet. This is just one of the many enigmas surrounding Uranus, a planet that challenges our understanding of planetary formation and behavior.
The most widely accepted theory for Uranus's extreme tilt is a cataclysmic collision early in its history. Billions of years ago, when the solar system was a chaotic place, a large object, possibly even a planet twice the size of Earth, slammed into Uranus. This impact would have been powerful enough to knock Uranus on its side, permanently altering its rotation. However, there are problems with this theory. If such a massive collision occurred, it should have left other noticeable marks on the Uranian system. Yet, Uranus's moons orbit in a plane consistent with its tilted equator, suggesting they formed after the planet tipped over. This discrepancy raises more questions than it answers.
Section 4. Cosmic collisions and planetary puzzles. Could other factors have contributed to Uranus's unusual tilt?
Some scientists believe that the combined gravitational influence of its giant neighbors Jupiter and Saturn might have played a role. Over millions of years, their gravitational pull could have gradually tilted Uranus's axis.
Another theory suggests that Uranus might have once had a massive moon, larger than any in its current system. This hypothetical moon's gravitational pull could have slowly tilted Uranus over time. Eventually, the moon might have been ejected from the system or collided with another object, leaving Uranus in its current state.
Section 5. Uranus, a window into the early solar system. While the exact cause of Uranus's extreme tilt remains a mystery, studying this icy giant provides valuable insights into the chaotic early days of our solar system.
The prevailing theory of a giant impact highlights the violent collisions that shaped the planets we know today. Further exploration of Uranus, perhaps with a dedicated mission, could reveal more clues about its tumultuous past and provide a deeper understanding of planetary formation in general.
By studying the unusual, we gain a greater appreciation for the forces that shaped our cosmic neighborhood and the delicate balance that governs our solar system.